I want to introduce our speaker, Alizé Papp. She will be representing Sweden, and she is a senior data scientist at Shopify. She has also participated as both a mentor and a mentee in our mentorship program, and is an industry leader at HyperIsland's Data Analytics program. So, Alicia, I will hand it over to you.
Smooth transition. Thank you. Okay. Yes, good morning, everybody. I will be talking today of a topic that's very dear to me, instrumentation, which is the very, very first step that we have in the data lifecycle. I think it's sometimes an overlooked step because people, might assume that it's like all obvious. And while working on it, I got to see that there's some subtleties about it, and I think it's quite a crucial step. If we don't do it properly, then the axiom of garbage in, garbage out. So yeah, let's talk of how to make sure that we have great instrumentation to observe our customer behaviors. A little bit about me before I get started. So like Katie mentioned, I'm a senior data scientist at Shopify, not Spotify. That's confusing to me too. I work there as a product data scientist, which is quite a generalist role, I would say. So it goes all the way from at the beginning, the data modeling, the instrumentation, the beginning of our data pipelines, all the way to actually leveraging that data for product analytics, A/B tests, some Gen AI use cases, and other fun things. I'm also quite involved at HyperIsland on the data analytics program, in the program steering committee, for instance. And being quite nerdy, I've also written quite a few research articles in different fields, social sciences, machine learning, etc. And on a more personal level, I live in a big collective with 50 people. I'm quite passionate about that as well. If any of the above tickles any interest, feel free to reach out and let's see if we can have a fika. So like I was saying, Shopify, not Spotify. What is that? Shopify is a big commerce actor. It's mostly known for its e-commerce platform, which enables businesses that want to get into e-commerce to create a website and get into that whole e-commerce game without having to know how to code. Giving that freedom. In terms of to give an order of magnitude, we're talking of since its founding about 20 years ago, more than $1 trillion GMV. So that's quite a big machinery that we have there. But myself, for the last 3 years, I've been working on the Shop app, which is a shopping destination and a delivery tracking app. So it's a mobile app created within Shopify, which currently has 150 million users. So quite a bit of users, but also we're tiny compared to the whole size of Shopify. So today I'll be talking about instrumenting user behavior, how we do that at Shopify, how that works, what that is. And then I'll talk of more precisely a project that I worked on, which had to do with creating instrumentation to support cross-platform use cases, and which really helped me see the subtleties that we have around instrumentation. And I'll wrap all of this up by giving you an overview of what the whole architecture looks like. Getting started. So user behavior and instrumenting it. What am I talking about? So I was saying we have 150 million users, right? And these users, they are doing a bunch of things in our app. They might be loading different pages, different screens on our app, navigating from one to the other. They might be clicking on things. They might be seeing things. Obviously, we don't need to know like of every single user behavior. There is a notion of privacy, and we don't need to like track everything. But sometimes for technical requirements or app functionality, it's good to know like to have some view into that. And so that's the whole thing of that instrumentation, of being able to from one behavior that the user had in our app, bringing that with I'll deep dive into what is happening here, but all the way to like having it in our data warehouse so that we can support all our different use cases. In terms of use cases, what I'm thinking about, so I was mentioning product analytics. Maybe we want to like measure our KPIs, our key performance indicators. We want to see like how users, if we have a new feature, how users are embracing it or struggling with it. Like that also, instrumentation also supports our A/B tests, which help us decide whether we should ship a new feature or not. But there's a bunch of other use cases that we have with that data. One of them is recommendation engines. So on the app, we like have different products from the different Shopify merchants. And we might want to know which, out of all these products, which one to show to our users. And so if we track that like, this group of user is super interested in this type of product, if we have good information on that, then we can make good recommendation for the user down the road to surface the right product for them. That's one use cases we might have. And yeah, last use case I want to mention is analytics for merchant themselves. So the clients that we have, like Shopify, is B2B. So we're surfacing products from Shopify merchants, and they might be interested in knowing how many people saw their products, how many people bought the product, all of that, to be able to support like all these use cases, from product analytics to supporting analytics for our merchants. This is what like that first instrumentation steps helps to cover. Okay, so let's deep dive. First step into the deep dive, looking into like technically what that instrumentation is. The way we do it at Shopify is with the first break, which is Kafka events. What is Kafka? Kafka is an open source library that was initially created by LinkedIn and then open sourced to send high volume, so a lot of data with a high velocity, very quickly. So we're sending loads of data very quickly, and we're sending it in a streaming fashion, which for those who don't know, like haven't heard of like batch versus streaming, when we send things in data in batches, we send them in groups. Like it can be big groups, but there's going to be some stuff in between. When we send streaming data, we're sending it continuously. There's a continuous flow of data that's coming in. And that data is specified by a topic, which is a way of saying this message from Kafka is different from that message. It helps us identify which big category of messages it belongs to. Right, but with just our Kafka events, if we just took them in their raw format, that would be quite complex to exploit. And there's a bunch of like standard transformations that we need from these Kafka events. And so for that, to help with that, we have an in-house library at Shopify, which is called Monorail, that does a bunch of these standard transformations. So I think a very important, like there's some nuance that goes in there, a very important transformation or like operation here is to enforce a schema. So what is a schema? A schema is a description of what the Kafka message should look like. So if we take the example of like we have a user and that user loads a page. We might have an event where the topic name is page load, and with a bunch of different fields. Like we might have a field which is called user ID that has the ID of a user, and it's described as a field that should have a type integer and which should not be nullable. We always want to, there should always be an ID for our user. Like that's one type of schema that we might have, and then we would have like different other fields. Maybe we have one for the timestamp of when the user loaded that page, and another one like to name the page, to say like this page was different from that one. So these are different pages that our user saw. So yes, for all these different events, we'll have a schema. And why is that schema important? Because it guarantees us that down the road, when we're like ingesting the data and supporting all these use cases I was talking about, make sure that things are following a certain pattern, following that schema, following what the format that we expect, really, so that we don't have things outside of that format that get into our data warehouse and goes and pollutes our data and make operation hard to do, surprising. Yeah, so that's quite an important step. We have like monorail, which is checking that like events that come in follow the schema. And if an event doesn't follow that schema, then it just bounces it off, and we don't want to have that. We don't want to have that event in our data. It also handles schema versioning, making sure that we have compatibility if we end up having different schemas, like evolutions in our schemas. And the less important point, it helps us handle PII, so private identifiable information. If we have any privacy concern over a field, like let's say that we want to include the email of our user in an event. We don't do that on page load, but let's say that we would. Then email is like obviously a private information. We don't want everybody to be able to access that. And so monorail handles making sure that the permissions are set correctly on accessing that private field, and also making sure that like we don't retain the information for longer than we're legally allowed to, so that after a little while, the information is scrubbed and not accessible anymore, to respect our users' privacy. Right, so like to recap all these different things together, we have a user that has some type of behavior on, I'll be using, I think that word a lot, on the client, on their mobile. And when that click, page load, when that behavior happens, we'll be emitting a Kafka event with a given topic name that corresponds to what that user just did. And then we'll have like monorail that is doing a bunch of operations, like the ones I was describing, to check that the event has the right format, handles versioning, handle PII, and other things. And when that is done, then we'll be ingesting the data from monorail, doing a bunch of operations. Maybe we need to union different versions. Maybe there's some things we want to change, filter out. Anyway, like we'll end up with clean data that then can be used for all the different use cases I was mentioning. Okay, so that was the simple version of it. And now let's add 2 platforms where we're doing this. Right, so it's been like a little bit more than a year now that Shop is also accessible from the web. So we have a mobile app, and we also have a web app. If you go in your browser and you type in shop.app, you'll actually be able to access that page, and you'll see something quite similar to that screenshot I took. And so comes the whole question of like, we want to be we want to be able to track our users like we were doing just on the mobile app. But now we have two different platforms where we're doing that. And so that's a project that I worked on for about a year, of creating from scratch like all the instrumentation on the web app and making sure that it works and it's compatible for use cases where we want to do cross-platform analytics. Really, there's two possible designs that we could go with, unified or separated. If we go with the unified approach, it means that we have the same systems, the same schema, everything is the same for both our platforms. If we go with a separated approach, then we create a bespoke system for every platform. But then down the road, if we want to have cross-platform analytics or use cases, at some point we'll need to union things in a data warehouse. So these are the two different possible designs that we can have. And I'll be showing you like the trade-offs of both these approaches. The first thing, quite an important one, is that there can be differences, and there were differences between how things function on a mobile app and how things function on the web. I think the starkest one is around user identity and tracking it. Yeah, let me explain that a little bit. When we're like on a mobile app, we have all our users come in and they have a user ID. And so we can identify them. Like there's some subtleties around that, but overall, like it's quite straightforward. When we arrive on the web, we actually have a nature of the traffic that's quite different. Like we can have users that are not logged in. They don't need to have given their email address and gone through verification steps and all of that. So we have users that are not logged in. And amongst these users, we have bots. We have like bots, like crawlers, that are going and visiting our website automatically to like have an idea of what is happening there and index all the content. That's like, for instance, for SEO purposes, to like, if you think of like Google search results, for Google to surface things, it needs to like have an index, have an idea of everything that's out there on the web. And these bots actually represent a significant portion of our traffic on web, which is not at all something that we were used to on mobile. So around like the identity of the user, really things are quite different on web. We don't want to have a user ID for all our users, because like these user IDs are linked to creation of rows in tables in our server in the backend. So we don't want our tables in the backend to explode just because there's a new bot that's crawling the website. We don't need to have a row that keeps track of that user. So we have a user ID, which is for logged in users, which means that when a user is not logged in that page load event, we are sending a null value. And I was saying, up until now, we always had a user ID. So up until now, the field user ID was non-nullable. And when we extend it to web, then we need to have the field be nullable, that it can have null values. And the null values are quite common. And on the web, for all users, we have a user token, which is based on cookies, which is a field that we absolutely don't have on the mobile app. So if we go with separated designs with two different topics, then the user ID will be non-nullable on the mobile app, and user token doesn't exist on the mobile app. And on web, we will have user ID, which is a nullable field, and user token, which is a non-nullable field, and that we absolutely need. If we go with a unified design, so just one schema, then we need to change the schema that already existed for the mobile app and generalize it so that it can also be compatible with the web use cases. So we need to make the user ID field nullable. We need to create a user token field, which is also nullable for when it receives values from the mobile app. And then if we want to still make sure that the data we're sending down the road in our data warehouse, and we don't want to have garbage in because we don't want to have garbage out, then we need to have some type of service that enforces that the nullability, in that case, the nullability constraints that might be different between both platforms are still enforced. So we have something that watches and sees if from mobile we have any values for user ID which are null, which should not happen, and reciprocally for the other fields on web. So like these two approaches that I was talking about, being unified or separated, both of them are very valid. But in both cases, there's some things we need to put in place to make sure that things function. Second difficulty, thinking of our use cases downstream. Right, I was saying like we have that data that flows in, and at some point that data will be used. If that data is used in a use case which is separated, if we went with a unified design, it means that we will need to filter out to like only the data that comes from the mobile app, or only the data that comes in from the web app. If our use case is cross-platform and we have a unified design, then things are coming in with already like all the right formats, with already both web and mobile information. If we went with a separated approach and then we have a cross-platform use case, then that becomes a bit more complicated, because in that separated, if we have a separated design, so we have two different schemas, then it's when we actually need to union things, then we'll need to figure out how to union things, how it makes sense to pull together, like which fields go hand in hand together, and how to handle the fact that like for things as basic as identifying our users, things may not match perfectly. One last thing I wanted to mention on all this is really like working on this project, I realized that there's a lot of like our definitions of our business concepts that really rely on instrumentation, where it's really important that we define things properly so that down the road we know what we're measuring. So like something as simple as what is a user, like this figure, like a KPI, a key performance indicator that's well used across the industry, is the monthly active users, MAU. So the number of, in the month, how many users were active. It should be straightforward, right? It's just like we take all the users that had, like, for instance, like at least a page load, and we count how many different users we have. Right, but the difficulty here is like we have two different fields that describe our users. So they really ask questions of like, should an active user, should that be only a logged in user? Should that be a user that had at least, I don't know, a certain number, like 10 page loads? Or should it be like all the users we can detect, with the risk then that we'll be counting web crawlers, so just bots, into our users, which would be like quite, which would definitely not be a good measure. These are not real users. So in all these cases, there was I think the key is really thinking of like, what is the business logic? What is the thing we want to measure and to know about, to define things properly, and then instrument in a way that is coherent. Yes, so like I was saying, we had two possibilities for the design, between unified or separated, and depending on how we go, on the side of the schema, we might have to we'll have to design things differently on the unified versus the separated case. And in terms of use cases, I'm out of time.
Yep. Sorry, but you can wrap up. Go ahead.
Yes, I'll wrap up. Like, yeah. yeah, I'll wrap up with that one. That is actually my wrap-up site, so that's perfect. We ended up going with a unified approach. So we have one topic where, like, from scratch, from design, we have, like, we know how things are supposed to look like. We have that bespoke system I was talking about that checks that for constraints that are just specific to one platform, that these constraints are checked in and all good. And then we have, like I was presenting earlier, like all our data pipelines, all the way to having clean data that can be filtered using the platform field on, like, only mobile or only web to like support all our different use cases, whether they are per platform or cross-platform. Thank you.
Thank you so much, Alizé. Thank you very much. Super interesting. I'll just quickly introduce myself. I'm Lena. I will be doing Q&A and then the panel later. So we're going to go through a few questions really quick because the next speaker is coming up in 3 minutes. So we're going to go ahead with the first one that came in. What is the main purpose of using a separate schema?
Yeah, that's a good question. Like, there's just like these things that are different on how things function between the web and a mobile app. So, like, taking that example of a user, like, we don't have, like, on the mobile app, we were used to relying a lot on the user ID. And then when we arrive on web, that user ID is coming from the backend, from, like, things that engineering programs. And so when we arrive on web and we don't have that user ID, and we have it only for logged in users, then there's a question of, like, okay, how do we identify our users? And that's when we, like, use that cookie and the user token. So there's things that work differently between a mobile app and a web app, where, like, having separate schema can help adapt to the specificity of the platform.
Great. I think we have time for one more real quick. So let's say we can go ahead and ask, well, same person, but it was a good closing question. Where can we learn more about this? Web pages, articles to suggest?
I have, like, some like I use Medium a lot myself to train. So I think, like, reading on, like, Kafka events, analytics. I think Amplitude also has a really good documentation on the topic, which is like a third-party solution for companies that don't go with in-house solutions. So yeah, these would be, like, good places to check. I can send some links if there's a way of, like.
Yeah, I think you also have some other really interesting questions in the chat. So people feel free to reach out to us. Or you can take it in the chat as well. Feel free.
Absolutely, yeah. Definitely reachable via LinkedIn, and we'll try to answer some questions here.
So feel free to send the links in the chat and answer questions. So thank you so much, Alizé.